I will go a bit into a short recap on the general SSO architecture. I will talk about multi-master replication, talk about what service endpoints are, what solution users are, a bit about backup and restore, and also login performance impacts that might have or create issues for your SSO environment. So let's directly jump into the first topic, which is the SSO architecture. But before we do that, let's just remember what SSO is for. It introduces a mechanism for token-based authentication, meaning that you only have to provide your login credentials once, and then a token will be generated out of your credentials and distributed among the services that are registered within SSO. These services register with to SSO via a concept called solution users, and they are communicating and authenticating each other using SSL encrypted traffic. So in a nutshell, we, since 5.1 and even better in 5.5, we do now have a separation of duties due to the introduction of SSO. Which, sorry for the sound, that was some web browser playing in the background. So in a nutshell, we do have separation of duties now, with SSO actually handling the responsibilities for authentication, and the registered services will take the responsibility of authorization, which is, for example, why you will be able to log in into the web client even if you do not have VC admin permissions, due to the authentication actually succeeding, but you're not authorized to use anything. So since SSO 5.5, we actually have split up the services a bit. In 5.1 we had one single service. In 5.5 we have made 5 sub-services out of that one single service. And the basically most improved component is the VMware Identity Management Service. This is the part of the software that used to be written by RSA and has been completely rewritten. And this allows basically greater control and flexibility in terms of enhancements or customization. The secure token service is the main service that customers actually will interact with. It's dealing with the issuing of tokens, with their delegation, renewal, and also their validation. And it serves as a wrapper for the lookup service, in which all components that get registered against SSO register to, and also for the admin service, which handles basically everything for configuration of SSO. The next two services then are more or less internally used services for SSO. This would be the Kerberos service, the KDC, and the certificate service. And they are used for internal Kerberos ticket authentication and for the creation of the default certificates, which will be created at installation time for SSO. The certificate service will be bumped out in the next release of the software. Currently, the release candidate is available in public beta. NDA still applies, so I'm not allowed to talk on that too much, but you can basically download the bits and the documentation to see what this service has actually evolved into. The last service is then basically the part we are going to talk about today. That is the VMware directory service, and this is the heart of the SSO in terms of where configuration is stored. everyone that knows SSO 5.1 knows that there was a database attached to it. We basically got rid of the database, and VMdir, the VMware Directory Service, is an LDAP compliant service that serves as the internal database basically now. So what is stored in VMdir? We do have security certificates, all our policies. We've got SSO local users and groups, and also identity source configuration. It was also kind of available in 5.1. We called it system domain in there. We also have rebranded that name to be vSphere.local in 5.5. So when talking about SSO, there's actually many ways you can access SSO with. The three major ones I will introduce now. So the first one, and also the most powerful one, would be an actual LDAP browser, like for example JExplorer. This will actually expose the whole directory structure and allow direct CRUD, so create, read, update, and delete operations on the data itself. The same is possible via command line tools like LDIF or LDIFD, but you should keep in mind that this is the lowest level you can actually access SSO with. There is not many restrictions on what you can do. So, for example, you could actually delete important internal users and groups that you could not delete via a GUI, and drive SSO to a point where it is not repairable anymore and needs to be actually reinstalled. There is a question. Chris, can you just pop the question into the questions window? And while he's typing, I'll continue to talk. So the to actually get access, you need a certain set of login credentials for it, and it is all LDAP based. So you enter the DN, and as a username and password, you will be taking the CN administrator, which is in the group users and belongs to the internal domain vSphere.local, and access it via the administrator at vSphere.local password. The only thing to note here is the actual port. We are not binding via the default LDAP port of 389 or 636. We are actually binding via our own port 11711. If you're missing out on that portion, you will not be able to actually establish a connection. Once we then hit OK, we can see the whole VMdir configuration in front of us. I will go into detail about some of these containers, but this is basically how everything is represented internally then. Under normal circumstances, you would not actually use this interface though. VMware actually recommends that this only should be used under GSS guidance, or if you are following a well-documented KB article. The preferred interface from a VMware point of view would actually be the web client. So using the web client, you can actually do most configuration you will be able to do in SSO. You can delete solution users that are stale. You can add local SSO users and groups. You can edit identity sources and also the password policies. And by now, everyone actually should be comfortable with this interface. It is going to stay. So if you're not, I highly suggest you to get used to it. There is actually a third interface that we sometimes need to repair certificate issues, for example, due to the fact that in the web client you cannot modify any endpoint data for endpoints registered in the lookup servers. And therefore we've got the SSOLS CLI. It serves as a lookup service front end, and again the lookup service is the service where every component that registers into SSO in the end will be registered to. So everyone that at some point manually reconfigured certificates for the vCenter server will be familiar with this interface. Each service registers for a so-called service ID. It does have an endpoint, and that endpoint usually is the SDK interface. One of the actual best features that we have now in SSO 5.5 is the multi-master replication. So I also wanted to talk about this because basically we are replicating VMdir. So it fits perfectly into a VMdir deep dive as well. And why did we actually need the multi-master replication? Everyone that had to set up a linked mode SSO setup in 5.1 will basically know that the procedure was kind of elaborate. You had to install the first node, register all services against it, then export the data, import it into the second node, register all services against there, export the data back again into the first node. And this basically continued for each and every node you added, and you needed to export it back to each and every node in the end, kind of like the Towers of Hanoi. So after you had like 5 or 6 separate SSO servers in linked mode, that concept just completely stopped to scale. So what's different in 5.5 now? There is basically an automated way to do that. It kind of works like Active Directory in terms that we also use replication agreements and a multi-master replication part, which means there is no specific master node that holds all the data and then pushes the replicated data off to the other nodes. Each node is basically created equal in the replication process. And it actually works via agreements. These agreements make the replication happen. Each time you're setting up an HA or multi-site deployment for SSO, you're actually creating replication agreements with the partner node you're giving through the installer. Replication does happen inter and intra-site, so no matter if you are setting up SSO HA or linked mode SSO, it will not affect replication. Replication will always happen. During the actual install, you are giving the installer a partner node, and between the installed node and that partner node, a replication agreement will be set up in a two-way fashion. If you're installing more than 2 sites or 2 nodes, we will not create a full mesh structure. This would need to be manually created, and you will see that in the example I have in the next couple of slides, what I mean by that. Replication itself happens every 30 seconds. And for the data that actually gets replicated, we're replicating solution users, service registrations, SSO users and SSO internal groups, and also policy changes. The ports for the replication are actually twofold. It is port 11712 by default, which happens in an encrypted way. And if we cannot establish a LWS connection via that port, we will automatically fail back to port 11711 as well. So you should make sure that those ports are actually open in the firewall between SSO nodes. The replication of the service endpoints and solution users can also have a small drawback to it, actually. I have dealt with cases where we had a replicating SSO setup, and the customer actually wanted to repoint the vCenter service to the other SSO node. The repointing actually failed because it could not deal with the solution user that was actually already replicated over there. So the solution was pretty simple, to simply delete that solution user and run the repoint script, but that is something one should be wary of. When taking a look under the hood, again in VMdir, in an LDAP point of view, we can actually see that replication agreements are saved under the configuration subtree. So for each SSO site that you're creating, you will get a site name, and in there you will have all SSO servers within that site, and each SSO server will have its own replication agreements. In this example, you're not able to see any because it's a standalone setup. But if, for example, someone had like a star structure, so a central SSO with loads of robo offices around it, each of the robo offices only would show the replication agreement to the central node. And within the central node, you would actually see a lot of replication agreements to each and every of the single robo nodes. So how does this actually look like in theory? I will first go through the actual setup, how this would have been set up, and then we will look at a full replication cycle. So we are starting with our SSO deployment in Palo Alto. We are going to install our first SSO node. And since Palo Alto is actually an important site for us, we decide to make it an HA setup. So we do install in load balancer, and HA operation is only supported with a load balancer. It completely tends to break without one, so don't skip that step. And then we reconfigure everything for the load balancer. As a next point, we're going to expand our operation down to the lovely Corking, Ireland, and also open up an important SSO office over there. So this means we want to have everything connected and replicated. So we will install the SSO node in Cork with the third installation option. In the 55U2 installer, it's actually called multi-site right now, and point that against the load balancer of the Palo Alto site. And with that operation, once that node is finished, we will have a two-way replication agreement in place between Cork and Palo Alto. So if we do changes in either Cork or in Palo Alto, these changes will get replicated within a couple of cycles. Since Cork again was an important operation point for us, we also set up a load balancer in there and reconfigure everything for it to be highly available. The last point where we are going to expand to is Munich. And now in Munich, we don't want the HA option. Munich is kind of less important to us, so we actually only want one SSO server in there. But now we've got a choice. Since we do not have a automatic full mesh option for the replication agreements, we've got the choice to point it either against the Cork site or against the Palo Alto site. Depending on which site we are choosing, we will actually get the replication agreement. In this example, we are actually choosing Cork. So what does this mean now? If Cork is completely down, we will not have any replication going forward between Palo Alto and Munich. Once Cork actually comes up again, replication will be working out again just fine. So how will this, after we actually install it, how will this look like if we have an actual replication going on? So let's say we've got a certain user and do a password change of that user now. For everyone who's familiar with Active Directory, you will know that Active Directory uses certain IDs called USNs to keep track of changes. Every time a change is being done, one or more IDs just increase in their number. We are using a similar concept. To simplify this, I will only show one USN in these slides. In the background, it's actually quite a bit more complicated with a bit more numbers, but for the example, this should suffice. So once the password has actually been changed, the USN will get updated on the Palo Alto side. The actual replication then is not a push replication. So Palo Alto will not push out to the other node that it has done any changes. The replication is a pull operation. So each node will pull from its partner nodes for any updates every 30 seconds. As it can now happen that this happens kind of random, it might actually be that Munich pulls before Cork, which will mean that Munich won't even see an update. So even though the replication cycle is 30 seconds, it might actually happen that if there is a very spread out infrastructure, that replication takes 2, 3, or 4 cycles to actually get to each and every node. You can kind of imagine that like throwing a stone into the lake and then seeing the waves spread out. They take longer from the center to the shore. So yeah, in this example, Cork is not in the row for polling right now. It's Munich's turn. And since Munich only has a replication agreement with Cork, it will poll Cork for changes. And it doesn't see actually anything. So the actual password change will not happen on Munich right now. A couple of seconds pass, and now it's Cork's change to actually poll information, and Cork will basically poll information from Palo Alto and from Munich on both sides. And it will see, okay, something in Palo Alto changed, the USN of that user changed, and it will poll the change. So the USN in Cork also increases. And after a couple of seconds again, we have passed the full 30 replication cycle for Munich. Munich again will pull information from Cork. And since Cork now has the latest information, we'll also see that there is a difference and fully replicate the changes for that one user. So this means actually Munich needed 2 replication cycles to get the changes for that one user. So for the troubleshooting from a support perspective, the main issues I've come across are most of the time external issues, firewall being number one, wrong DNS names being number two, and if customers reinstall SSO quite often, which thankfully doesn't happen too often anymore with 5.5. I've also come across a couple of issues with stale partner certificates. And the last case I see on a regular basis is if no actual replication agreement has been created between two nodes. This actually happens quite often when customers choose to install vCenter with SSO on node 1 and then also do a simple install with vCenter and SSO on node 2, which are not linked by default. And yeah, so there's no replication agreement between those two SSO nodes and no replication will ever happen. So what can you do to actually remediate this? For the external issues, it's pretty easy, fix them. So open up the ports 11.7.11 and 11.7.12 in the firewall, fix the DNS names. It's really surprising how many stale DNS entries actually exist out there if people block dynamic updates for security reasons. So regularly running dcdiag can actually already help a lot. And for the stale partner certificates, you can actually delete the partner certificate in its respective folder, which is listed here. If the certificate is not pulled again within, let's say, 2 minutes, you can also just copy it from the partner node. That basically has resolved most of the replication issues I have actually come across. If it is the case that there is no replication agreement between nodes, for example, you definitely want the full mesh for your 5 SSO sites, it is highly suggested to simply open a support request with GSS to be guided through the procedure instead of doing the low-level stuff yourself, which might really mess SSO up. So I have actually talked about service endpoints already, and service endpoints are the some of the things that are replicated and one of the major SSO features as well. So as I've already shown, each service endpoint has a specific ID. It also has a protocol type, which has internal use only, so you won't be able to customize much on there. It does have an endpoint service URL for basically all services I've come across that register with SSO. It's the actual SDK URL, and it also has a so-called trust anchor. And by trust anchor, we mean an actual SSL certificate. For the usage, since the service endpoint URL is the SDK interface, SSO knows to which URL to go to actually present the token and ask the service to validate that user in terms of authority. So if that user actually can access that solution. So what happens when you log into the web client? You will get your token, and then SSO will go through each service endpoint that is registered into the lookup service and ask, here's the token for that user. Can that user access you as a solution? Yes or no. If it is a yes, it will be displayed in the web client. If it is no, it simply won't be displayed. And how does this look under the hood. Pretty simple. It's no magic, and it's also in the configuration subtree for each site actually. So the lookup service will actually be shared within a HA setup. And again, also from the SSOLS CLI, where you at least have some abstraction. You can do most modification for the lookup service endpoints via properties files. So in program files, VMdir, and either infrastructure or the program files directory itself. Each service that's registered within SSO will have a so-called properties file. And if you're running SSOLS CLI without parameters, you will actually see that there's a name tree called update services, which wants to reference that properties file. So if you have to do any changes, the most common use case I can think of is if someone, for example, during a vCenter install, actually gave the wrong FQDN. So most of the time where I see this, the customers give the domain FQDN, so domain.local instead of vcenter.domain.local. The system will just install fine, but the endpoint URL will be broken, which most of the time results in that the customer doesn't see the vCenter in the web client. So you update that properties file and run the SSOLS CLI update services to make that change persistent into the lookup service as well. Then you restart the vCenter server and everything is fine on the web client. Other main issues we are seeing is also that when SSL replacement goes horribly wrong, stale and outdated certificate information is in the lookup service due to a failed rollback. If you're renaming systems, like the company gets bought by another company and there's an impending domain change, happens more often than I would have thought before starting at VMware, that can mess up the endpoints as well. And also, if SSO is down during an uninstall, it will actually have issues with stale information. And this technically is an unsupported configuration, but it happens all the time. People just let expire the certificates. And the lookup service actually has an issue with that. So what can you actually do? Most of the time, and this will be repeated for the solution users as well because it is really, really effective, at least if you know what you're doing there, is to remove the solution user and the service endpoint. And then if that solution is still active, simply use the readpoint script of that solution. This will recreate the service endpoint and also the solution user. An example on how to do this can be found in those 2 KB sorry, in those 2 KB articles. As I have already mentioned the term solution users as well quite a bit, it's also time that we take a closer look at that because, again, this is one of the main concepts of SSO and VMdir especially. So a solution user is basically the principle that is being used to authenticate registered solutions. They do register as an endpoint via an URL, but their representation in SSO happens via a so-called solution user. And this solution users actually do not have a username per se. They get registered by the subject DN of their certificate. And that's basically the reason why you need 7 different certificates on the same vCenter box. Even if it is the same system, the CN, so the common name, the FQDN of that system is the same for each and every service, you will still need 7 different certificates because there's 7 different services on the system that actually integrate with SSO and with solution users. Some of them could be duplicates. For example, SSO itself doesn't have a solution user, so the SSO certificate could actually have the same subject DN as vCenter, for example. For the default installation stack, you've got 4 major solution users. So default stack meaning everything that's on the vCenter ISO, the web client, the inventory service, vCenter server, and vCenter orchestrator do have a solution user. Orchestrator only creates the solution user after you actually have configured it for SSO. The web client itself also has a subcomponent called the log browser, and the log browser uses a second solution user actually for the SSO. So that's why you will find also 2 service endpoints for 9443 in the lookup service registrations if you look for that. The solution users are part of a special group because to actually determine your rights for each service endpoint, they need to have certain permissions, and these need elevated rights. So they are all part of the so-called solution users group. You can actually look at that group in the web client, but all solution users and all members of that group are actually hidden by default. I have seen cases where we needed to manually add vCenter to an SSO server because the repoint script was somehow broken. Tends to happen in specialized language environments like German or French, for example, where you've got sometimes funny characters like umlauts. And if you can't do the repoint via script, you simply create a solution user, you create a server's endpoint, and then suddenly your users still can't log in. That is why, because vCenter can actually not determine if that user has the permissions, because it cannot do certain API calls as a guest user. So to remediate that, you would add the vCenter server solution user that you had just have created also to the solution users groups, which makes it a regular user in SSO again, and then it does have the permissions to do these API calls. And yeah, as already mentioned, they actually identify via certificate authentication and not really via username or password. And yeah, each solution user usually maps to a service endpoint with inventory service being an exception here. Inventory service does only have a solution user. It does not have a service endpoint, but it does have a one-to-one relationship to vCenter server, so it can be identified via that vCenter service endpoint. And there is where the service principals are actually saved. So service principals basically just is an internal name for the SSO solution users. And here is how they would look like in the web client. If you look at the naming convention, you will see that for most services, at least from the vCenter stack, it will start with the name of the service, then an underscore and the actual first installation date of that service, and then we are also appending a a random number ID. So if you have more than one vCenter or more than one web client registered against one single SSO server, that you can still distinguish them. So what are the main issues that you could come across with solution users? During repointing, as I have already mentioned, you can also sometimes, if something goes wrong, lose the actual mapping to the solution users group, or if the script is broken and you actually have to do the repoint the manual way. If you're upgrading from, let's say, 5.0, where you could use the same subject DN with the inventory service and vCenter server, and upgrade to 5.1 or 5.5, the installer will not fail. It actually should, in my opinion, because it's not a supported configuration. Instead, it does kind of a workaround, which creates a new solution user certificate specifically for vCenter server. And that makes readpoints fail, that makes SSL certificate replacement fail, and breaks a whole lot of other stuff, so this should actually be fixed. And again, also expired certificates for solution users are never a good thing, as it completely breaks on that. And if you actually have replication issues, I came across this 2 or 3 times already. If there's replication issues for the solution users and you want to use vCenter linked mode and the inventory service replication user does not get replicated, you will get a warning in the web client that a connection to that vCenter server could not be established because the client is not authenticated. So fixing the replication, the underlying replication issue is actually key to get the link mode working then. So what can you do in most cases? Most of the time, for the first part, as already mentioned, you simply re-add the solution user to the solution users group. If you've got old certificate that are expired, usually removing the solution user and service endpoint helps, and then either for some services you can replace certificates, for others you need to reinstall the service while pre-staging the SSL certificate. And then again, after you removed everything and replaced certificates you didn't have to reinstall, then you would need to repoint to the SSO server. In case you actually have the second issue mentioned, the duplicate solution user certificates, there is a KB describing that issue, and there's also a KB, and that same KB actually mentions the steps to remediate it. What it doesn't tell people is that you actually first need to replace the offending certificate. In most cases, this is actually inventory servers. And again, just for reference, the repointing KB as well. Since vCenter server and SSO is actually enterprise class software, we should also just a tiny bit at least talk about backup and restore. So let's actually first take a look at how you would create a full backup that is not really image-based on the Windows SSO. So if you don't do full VM backups, but rather want to do a file level backup, this is all described in the following KB. And the high level procedure is gather an SSO log bundle just to have the configuration in place in case you will ever need it again. Back up a certain set of registry keys. Back up all the SSL certificates. And as the last point, you want to back up the actual VMdir database, which is saved on the file level, always on the same machine where the SSO services are installed. And there's actually a small batch file that you can invoke to get this done. This can be done in hot state, so SSO doesn't need to be shut down for it, which is a good thing. So this can actually be scripted overnight to simply put it down to an actual backup drive. The restore procedure then depends on whether you're having a single node install or a multiple node install. In single node, you basically have two outcomes. Either you can restore the actual guest OS on where SSO is installed or was installed, and then the procedure would look kind of like this. You stop all the SSO services. There is a particular order to stopping and starting the services. You first stop the STS, the secure token service, then the IDM, the identity management service. The certificate service is next, the VMCA, then the KDC, and lastly you stop VMdir. After all services are stopped, since you could actually restore the guest OS, which means that the registry is already in place, you will just copy the data MDB and log MDB that you've saved in the last step on the previous slide back into their correct folder, and then you can simply restart the service. Start order is basically backwards to forwards. So you start with VMdir, with the VM directory, KDC, certificate services, identity management service, and secure token service. If the guest OS cannot be restored, you actually have a bit more work to do. You install a new VM that has the same settings as the old VM, especially for hostname and IP. Afterwards, you're gonna go through the same procedure nearly. You're gonna stop all SSO services, same order as above. You restore the registry backup from the last slide. You restore all the certificates folders, and then again you copy the MDB files into the directory and restart the services, and you've successfully restored the actual SSO configuration and everything. In terms of multi-instance, it's actually a bit more complicated. There's a KB describing the procedure. Since update 2, there should be a new switch included that can force replication changes. But since I already mentioned it also a couple of times, we are pretty similar to Active Directory in that regard. And before 2012 R2, you were not allowed to snapshot and restore domain controllers due to the inconsistencies that can happen with the USN changes. And in SSO, the same thing can happen as well. So do not, in a multi-node setup, restore a very old backup or anything, or you might actually break replication. So how would you go in a multi-instance process? You actually would restore the guest OS, and then uninstall and reinstall SSO. You would restore the SSL certificates, and then you've got two choices. Since you can follow that KB mentioned above, and then actually have everything sync up, even if even after you've restored the MDB files. Or you can skip the MDB files, which I propose in the slides still. Since everything will be replicated again, you just need to wait a couple of replication cycles, and everything will be pulled from another node in a multi-node setup. I personally see the advantage of that being that you will not run into any replication conflicts or anything, and just get pulled the latest information onto that node just after a couple of minutes. The last part I actually want to talk about is the impacts on performance for especially logins. Since we also get calls on a regular basis in support for that topic. So what are the main issues we are seeing? We see performance degrading when users are in really a lot of groups. So to enhance login performance for users, try to keep group memberships to the absolute minimum. When the Active Directory service backend actually is very large, so millions of objects, I've seen environments where the people had like 10 or 12 million objects in Active Directory, which makes it very hard for the SSO server to actually find the user. Also, large number of trusted domains can be an issue. Due to the fact that vCenter also allows negative permissions on groups, and SSO will understand the concept of trusts, it needs to enumerate all the groups a user is a member of, because it could actually still be in a no-access group. So if you have hundreds of trusted domains, SSO will go through each of those domains to list group memberships. And if, for example, there is a firewall blocking access to a domain controller, SSO will actually wait for a timeout, which can severely increase login performance, or decrease login performance and increase login time. I've seen cases where actually fixing one firewall port brought down login time from like 2 minutes back to 10 seconds, which is a huge improvement. Yeah, external issues like DNS, sorry, like DNS and firewall can also hugely impact the system. And like trusted domains, also stale service endpoints can be a huge issue for SSO. Because it's the same. Each service in the lookup service will get queried. Do you know that user? Can you allow that user in? And if the endpoint is actually stale, SSO will time out while trying to communicate to that service. So what can you actually do to improve it? Again, keep group memberships to an absolute minimum. Don't have users